So I'm on a Linux host with Docker installed. We'll be on a Windows host later, but a quick look here, yeah, shows us we've got no containers running. Okay, well, spinning up a new one is as simple as docker container run. This used to be just docker run, which still works, by the way. Anyway, I want to log into this container. Wait, what? Didn't I just say that we normally don't log into containers? Well, yeah, I did, and that is right. But we're in a lab here dissecting stuff, so different rules apply. You'll see why in a second. Anyway, to make it so we can log into it, we go -IT. Look the flags up in the help if you want, but I always think of them as interactive terminal, IT. Anyway, then we tell it which image to use, and finally we tell it what process or application to run. I just need a shell. Okay, so the first thing to note, see how my shell prompt's changed. That's because the container is already running and we've switched our shell into it. We've basically attached the standard in and out streams from my local shell here to the container. So anything I type in here is going to run in the container. Coolio. Now, okay, actually, before we look at the output of that command, did you notice how fast the whole container start thing was? Like, maybe a second tops? And that included downloading the image from Docker Hub. Now, fair enough. The image we're using in this example is disgustingly small. Most others are probably going to require a few seconds to download the first time you run it, but you get the picture. This stuff is quick. Now then, this PS here, remember it's running inside the container. So we've only got these two processes running. It's only one really, because this one here is the PS command, which is already exited. So one process, which if we remember, plays nicely into what we talked about a minute ago when we said the gold standard for containers is the microservice model with a single process and concern per container. Fabulous. Now, things are a bit different over here in the Windows world. This is a similar PS command running inside a typical Windows container. And clearly, there's a little bit more going on here. And that's because Windows works different to Linux, right? We won't get into it, but the net result is every Windows container runs this handful of processes. SMSS here manages all the system processes, and PowerShell is the main app that I ask the container to run. Okay. Well, back here, right, if we start a bunch more of the same container, I use Control-P and Q to get out of the container, by the way. See how my terminal's back to normal? We'll talk about Control-P and Q in a minute, right? But keeping on track for now, we can see the container is still running. If we start another one of those containers, only this time in the background, please, -D for detached, or I think actually maybe daemon mode. Either way, it won't grab the terminal this time. And we'll tell this one to sleep. A good sleep. I tell you, what I'd give to sleep for a day. Okay, first up, that was closer to a sub 1 second start time. And that's mainly because we've already got the image on the host from the last container we ran. So it was literally setting up the namespaces and stuff really quick. And we should see two of them now. Right, so two containers sharing a single image. The containers, though, totally isolated from each other. We remember this, right? To stop one of them, we go docker container stop. Then we give it the name or the ID. If we go with the ID, right, we only need to give it a couple of characters. It's just after uniqueness. Ah, right. This waiting around here is because the container is being given 10 seconds to sort its stuff out before being forced to stop. We could go down a Unix rabbit hole here about init processes and signals and the likes, but I think suffice to say, right, stopping a container sends a signal to the main process in the container, PID1. If that process knows what to do with the signal, then it tidies things up and says, hey Docker, I'm ready to be stopped. But if it doesn't know what to do with the signal, like ours clearly didn't, then Docker gives it a 10-second grace period after which it forces it to stop. Alright, well if we list them now, we only see one. But if we slap -A onto the end here to list them all, okay, we see two again, and this one that's in the exited state is the one that we just stopped. So if we start it up again, you probably guessed it, we change stop for start. Run this. And it's back. Started a minute or so ago, but it's only been up and running for a couple of seconds. And the thing is, right, any data that we might have saved into it before we stopped it is all still going to be there. In fact, let's see that. Okay, yeah, let's do it. Now, look, this isn't recommended. Yeah, sure, you can save data into a container, but it kind of breaks all the containers are ephemeral and immutable rules. So in the real world, you don't want to be doing this. Use a volume instead. But we're in a lab just slicing stuff up here. So we can get into a running container with Docker container exec. Make it interactive again, give it part of the container ID, and we'll have another shell session. And we're straight in, right? Now, first up, look here. See how it's got a couple of processes going on now. That's because execing into a container starts a new additional process. So the original sleep that we started this container with, that's still snoozing away there. But this one here is the shell that we just started with exec. Anyway, we're in the root folder of the container here, so you know what, I'm going to be a bit naughty, and I'm going to pipe some text here into a new file right here in the root directory. It's a lab, people. We can do what we want. Don't do this in the real world. Anyway, there it is, right? That's our file. So if we exit out of this, this is going to kill the shell process, but it's going to leave the main sleep process alone. So we have to manually stop it here. And I'm doing it like this just to make sure we get the right container, yeah? Okay, stopped. Start it up again. Exec back into it. Actually, you know what? Let's do this instead. So instead of getting a full-on interactive shell session again, let's just run some commands in it. And that's our file. And if we cat it, that's what we wrote. So there we go. Stopping and then restarting a container does not destroy any of its data. Brilliant. Well, what was all this control P and Q business about? Well, we start a container. In fact, let me clean up a bit first. Okay, when we start a new container, we tell it an application to run. That's this bit here. For this container, it's just a shell, for shell. In the real world though, right, this is going to be your application. Now then, if we kill that app once we've started the container, we also kill the container. And it makes perfect sense, right? Think about it. A container is just an execution environment, right? A set of namespaces for an app to run in. So if that app exits, well, what's the point of the container anymore? There isn't one, right? So exiting the app exits the container. Simple, makes perfect sense. That means if we go into this container here, okay, and if I type exit, I'm telling the shell process to exit. And seeing as the shell is actually the app that the container is running, the container is going to exit as well. Quick check. No containers. If we run another one, so we're inside again, right? But if this time we go Control P and Q, see how we're back out, but this time the container's still running because we didn't kill the shell. That Control P and Q is a graceful way of getting out of a container without terminating its main process. Now, speaking of main processes, we can sometimes start a container without telling it a process to run here on the end. And look, we've still got a shell prompt. Why? How come? Well, every image has a default process that it'll run if we don't tell it something different at runtime. So if we inspect this image here, and this is it here, right? Command bin sure. That's what a container based on this image will run if we don't tell it something different. But like we said, we can override this when we start the container, a bit like we did actually with the sleep container earlier. And that's how the CMD instruction works. Anything that you tell it to run at runtime is going to overwrite what CMD says. Now, if the container was built with the entry point instruction instead of CMD, then anything passed in at runtime gets appended to entry point as an argument. I hope that makes sense. CMD instructions get overridden on the command line, whereas entry point instructions interpret command line stuff as additional runtime arguments. Okay, we've seen how to start, stop and restart a container and how to exec into them. Let's just finish things up with a quick look at ports. And you know what, we'll show some love to Windows for this one. So I'm running all of this now on Docker for Windows on my Windows 10 Lappy. If we go the usual Docker container run, we'll put this one in the background, call it Web 1, and we'll map port 80 here on the Docker host to 80 in the container. And we'll use IIS. And we don't need to specify a command because IIS runs automatically. So quickly, new container based on IIS, which has a default web server listening on port 80. Great, well, we'll map that through to 80 on the host as well. Alright, straight away we see a bit of a wait while the image gets pulled. This one's multiple gigs in size, right? But it's all compressed over the wire if you remember back to when we talked about content hashes and distribution hashes. Anyway, let me supercharge this. Cool. Now, a Docker port and then the name of the container, that's going to give us a list of the port mappings. This is saying 80 in the container, mapped to 80 on all interfaces on the host. Magic. Well, there's actually a bug at the moment that doesn't let you use the localhost identifier with IIS. But when they fix that, you'll be able to point your browser to localhost and see the web page. For now, though, I need to get the IP of the container. Lovely. And we'll hit that with a web browser. Beautiful. IIS. So there we go. That's ports. And that's it, right? So a quick cleanup before we look at logging. So this here is saying Docker container RM, remove or delete, and run it against the output of this block here, which is basically just a list of the IDs of all the containers on the system. And then we're forcing the operation so we don't have to do a separate stop first. Okay, cool. Let's go chat about logging.